All right. So in part two, we're going to talk about setting up relationships between different tables and why this is so powerful. And we saw a little bit of this yesterday in terms of designing, but we didn't really get into the coding part. So there's three kinds of relationships, right? There's one-to-one, there's one-to-many or many-to-one, and many-to-many. And let's build a one-to-one relationship for some employee information. And I'm going to modify this a little bit, but we're going to have one table that lists my employees and their names, and another table to hold sensitive information about those employees, like social security numbers and maybe like, insurance numbers or something, or insurance IDs, because maybe that way I can add some data protection. And let me hop over to draw SQL and let's create a couple tables here to go ahead and do this. And there we go. And we're just going to have to zoom out a bit because this is way too zoomed in. There we go. So we're going to have a table of employees. And then I'm going to have another table. And we're going to call this, let's call it employee private data. Not very, or let's just name it private data so it's shorter. Not a very innovative name, but it does the job. And our employee will have an ID. Our employee will have a name, right? And we're going to keep it simple. And then our private data table will have a primary key ID. It will have a reference to the employee. And this is the foreign key that we're going to create in just a second. And it will have an employee social security number. And we'll just call this an int. And we'll say that it cannot be null. And that it has to be unique because no one can have the same social security number. And let's add a field for insurance ID that will also be just an integer. And again, we'll say not null and unique. And employee ID, I want to make this a foreign key that points back to my employee table. So I'm going to go ahead and just draw that. And in the diagram, I can say what the relationship is. And this is one-to-one because an employee has exactly one and always exactly one social security number, insurance ID, and whatever else I put on here. And so this is my high-level data model. Let me go ahead now and write some SQL to implement it. And we're going to create our employee table, and it will have an ID, which will be a serial primary key. And I'm going to go ahead and just copy this. And we're going to do this for our private data table as well, because that's going to need an ID as well. And so our employee has an ID and they have a name, which will be a varchar, and we'll say not null. And then for private data, it has a social security number, which will be an integer, and we'll say it has to be unique. And if it's unique, I believe it cannot be null, but just to be safe, we'll add not null. And we'll add insurance ID, which is also going to be an int. And probably we can make it unique, but just for simplicity, we'll just say not null. So far, so good. But what I don't have is the relationship between these two tables. And to do this, we are going to use a foreign key. And in Postgres, to do this, we can use the keyword references. And they have foreign keys listed here under their constraints documentation. And their example has a table for products and then a table for orders. And we can see that what they do here is they use this keyword references. And again, this looks like a constraint. And we see the name of the table we're referring to and the column on that table that's going to be our ID key. Right. And so for us, what we will have is employee ID. And we'll have, let's call this an int, and we'll say references employee and then ID. And so now I have a table of employees and a table for private data. And I've implemented my data schema that we've kind of modeled out here. But let's see this in action. Let me create a couple employees. And we'll just do Alice, Bob, Carol, and I'm going to go ahead and run this SQL. And let's actually create a database. Relationships, let's connect to our relationships database. And let's run this SQL there. And we'll do foreign keys.sql. And it looks like I have a syntax error, and it says it's on this line, line 13 in my file, which is not quite line 13. It's here in line 11. And the error is actually a line up. I forgot a comma. So we do have to kind of be careful when we're reading these error messages. And now we see all of this seems to work just fine. See drop table, create table. SQL is telling me it's creating a table for the first time. And if I do select star from employee, we see my employee information. So far, so good. But what about this private data? Let's take a quick look at our tables, right? We see we have an employee table, a private data table. The employee table is pretty straightforward and what we've come to know and love. We see here the ID and the name, our next sequence for the serial auto incrementing ID. And if I look at private data, we see something interesting. We see the ID, we see the employee ID. And then down here, there's a new section here and it says foreign key constraints. And it's telling me that this employee ID is a foreign key that references from the employee table this column ID. Now, why does this matter? Let's create some insert statements for my employee private data, and let's see this in action. So let's do, and in fact, let's take a quick look at my employee data. Let's do select star from employees. And we see that Alice has ID of 1, and Bob has ID 2, and Carol has ID 3. Because we're going to kind of need to remember those when we use this foreign key. So I'm going to do insert into private data, and we're going to insert employee ID, social security number, and insurance ID. And let's do values, and let's add in some data for Alice. And I'm just going to make up simple things for the social security number and the insurance ID. Now let's give Bob something. and these have to be unique, right? My social security, I can't have two employees with the same social security number. And let's insert some data for Carol. And oh, let's insert some data for someone that doesn't exist. And let's run this and see what happens. So when I go ahead and I run my code, we see a couple interesting things happen. First off, we see an interesting error message. Error cannot drop table employee because other objects depend on it. So this drop table statement is no longer sufficient. Postgres knows that because of this private key here on the foreign data table, private data depends on employee. So it will not get rid of a table that other things depend on. And we'll talk about in a minute how to tackle that. And they give a hint here, use drop cascade, which we'll see in just a minute. Thankfully, I didn't modify the employee table, so that doesn't cause any problems. And we see here a bunch of insert statements. I was actually expecting to see an error for this one for an employee that doesn't exist. So let's take a look at our data and see what we have. My employees look the same, but let's look at our private data table. And interestingly, I thought the foreign key constraint actually should not be allowing this. And I think there's a way that we can rewrite this. So I actually had expected, I'm not gonna lie, I had expected that constraint to be enforced. And I was hoping we could see an error there, that it was going to say that like employee with ID 4 does not exist. So I think I must have done something silly there. And I'll come back to that in just a minute, but I just want to pause and check in here and see if folks have questions or stuff that we're curious about this foreign key. Tony, yes, sir.
I was about to ask, is it because you have a serial for the ID that it would just create ID for, and that's what you're referencing?
No, I don't, because if we look at, let's look at the employees. Um, oh, actually, this may be why it worked is because, um, actually, that's a very good point. So I jumped the gun here. I was doing my select statement and I was looking at the data, but I wasn't actually looking at what I was seeing. And I actually do have an employee here with ID 4. I, in fact, have inserted employees twice. Um, Now, this is a good example of where the unique constraint is useful, because maybe we don't want people with the same name to be able to be inserted. And so this is a good example too of how one error can cause other issues. So I was expecting this table and its data to be dropped, but it wasn't because Postgres said this depends on this. And there's two ways to solve that, by the way. One way is we have to reorder the sequence of table creation and dropping, but this is going to be tricky because like if I go ahead and we're going to drop private data first because it depends on employee. So we need to drop it before dropping employee. Because now we drop private data. And then when we go to drop the employee table, Postgres will say, hey, nothing depends on this. I don't have any foreign keys pointing to my employee table, and it should drop that. And if we go ahead and run this, and let's see how we do. So we see those drop table commands work just fine. And now we see the error that I was expecting to see before, where it says error, insert or update on private data violates foreign key constraint. Detail, key employee ID 4 is not present in table employee. And so this is a great example of how, even for a relatively simple program, I really have to, I think the secret to debugging is always looking at the data and trying to get data so I can try out different theories. Because it's easy for me to guess or come up with a good reason why I think something is the problem. But this stuff is so complicated, there's many different possible causes. And whenever I can get real world data, that's my best guide, right? And I can sort of Sherlock Holmes it and follow the clues. And so now we see our employee table only has 3 people in it. And if we look at that private data table, we see it inserted just fine, right? For those folks that had IDs that were valid. But then for this one, for the non-existent ID, that foreign key constraint kicked in, right? And this is what we're talking about when we talk about data integrity, because it wouldn't make a lot of sense to have private data for an employee that doesn't exist. So I just want to pause here and check in and see what questions folks have. Chris, yes, sir.
Yeah, I just want to see what happens if you move line 26 up to line 23 or in between line 23 and 24. That will
If
the
I move
data
what?
still will the remaining insert statements still carry on, or
They will.
once that error throws, will it stop populating the table?
They will carry on. SQL, with each statement, an SQL statement ends with a semicolon. SQL does not stop, it runs the whole file. So that's a great point. Let's go ahead and clear this and let's go ahead and run this and see this in action. And so we see here that error message coming from line 23, but then we see these successful inserts, right? Because these are separate statements. Does that help
So if
answer your
if they
question?
were combined, yeah, so if those values were all combined under that one
Then the
insert
whole thing
statement.
would fail.
Okay.
And in fact, we can see that.
Thank you.
Yeah, yeah. If they were combined, the whole thing would fail because of this something called a transaction that we haven't really gotten into. But the way that a relational database works when it's doing a statement, there's sort of a design principle called atomicity, meaning everything succeeds or everything fails for an individual statement. And that way we can guarantee data integrity. And if you shoot me a reminder, Chris, I'll drop a couple sort of like reading links on that because we don't directly apply it, but it is good to be aware of.
Thank you.
Yeah, and in fact, the term is ACID, which is an acronym, which stands for atomicity, consistency, isolation, and durability. And again, think about a bank, right? If I'm moving money from my checking account to yours, I don't want moving the money out of my checking account to succeed and fail to put it into your account because that just means the money disappears. So we need a way to put that as one single transaction. And when we do that, a relational database will guarantee that the whole thing succeeds or the whole thing fails, right? And one of the ways it does that is with SQL statements, right? So if any part of a transaction or a statement fails, the whole thing is rolled back. And this can guarantee that the database always exists in a valid state. If we have thousands of people interacting with our bank database, It guarantees that things happening at the same time don't mess with each other. And it guarantees that once a statement has been completed, it's permanent and it's not lost, even if the power suddenly goes out. Um, and so this acronym ACID is good to file away. We won't directly use it, but it is a big part of why relational databases are valuable. And Alex, yes, sir. And I see there are a couple other questions.
Can you do me a Can you scroll up to the syntax of the tables? And I was just wondering because in the written curriculum, it has a syntax differently. It says foreign key.
Yeah.
Um, it says foreign key. It has a different
Yeah. That's a
syntax,
great point.
but I guess the question is, would it be best practice to start naming the ID, the primary keys for each table, the
No,
instead don't name them ID or
just name them plain old ID. We kind of do it
okay.
here for teaching purposes, but
Okay.
yeah, because that way, like when you're reading this code, like foreign key employee ID references employees employee ID, just to kind of help drive the concept home of what ID this belongs to. But in practice, there are so many tables and they all have IDs. And once you get used to it, it becomes more straightforward. So best practice is to just name that ID. You touch on a really good point, and let me zoom this out a bit so we can kind of see this. There's two ways of writing foreign keys. This does the exact same thing as this. References, it's just a bit shorter, right? Because we don't need this foreign key part in front. If there are some ways to get a little fancier with foreign keys and writing it this way, if I wanted to like make a composite foreign key, I could do that. But like 90% of the time you can just do it this way. But they both do the exact same thing. Um,
Got it.
yeah, good question. And again, I think the Postgres docs are a good guide here, right? Because if we look at their docs, we can see references. You can in fact make it even shorter and it will kind of figure out the primary key. And I didn't do that for learning purposes, but in practice, that's actually probably best practice. And you can make composite foreign keys, which is more advanced, and then you would use the foreign key syntax to do it that way. But for us, I think this is a nice sweet spot because it's simple and it helps reinforce I'm making a foreign key to a table, like to a specific column. Tom, yes, sir.
So the other day I was playing around with the on delete cascade command for using a foreign key reference. And my question is when it comes to inserting something and you get the is not present in a table or anything like that, are you able to do um, a check to basically like kick out the bad value before it pops the error? Because I noticed that if I was using the on delete cascade and it popped a bad value, it would sometimes just like delete a whole row that wasn't necessarily intended.
Yeah, the short answer is no. There's not a way to do that, unfortunately.
Got it. Okay.
Yeah. And I will talk about Cascade in a little bit. Um, yeah, and we do have to be a little careful with SQL on a practical level. Something like that, we might be dealing with a level up in the code, or it's kind of like when you write a function, but then you have other code that uses that function. Right now, we're sort of learning the very fundamentals of SQL, but we'll see that as stuff gets more complex, we either have other SQL using our SQL, or later on, like Python code that's actually generating SQL for us. And that will kind of help address the issue that you ran into. Arnold, yes, sir.
Just to uh verify what you said, so you can either use a foreign key or a references.
Yeah, that's correct. And in fact, they're both the same thing. And this is a foreign key.
Oh,
Um, yeah, there's just two ways to do it. And I think the way to think about it is the job of a foreign key, and let me grab my annotator here. The job of a foreign key is to reference the primary key of another table. And that's why you see those two keywords used, and that just to explain where the term reference comes from.
and
Does that help break it down a bit?
yes. And to follow up, I do see the code in the curriculum. They put foreign key and reference in the same line.
Yeah, you have to. So the syntax is, so let me actually, and let me in fact write this. Let's write it. Let's write it twice, and then that way, I think it'll be way easier to talk about. So there's two ways to do it, and let's put this at the bottom. So we have a little room, and let's say like foreign key. Example one. And example two. So in example one, on one line, we create the employee ID column and also create and also make it a foreign key. Right, so on this one line of code, I'm creating a column named employee ID. I'm saying it's an integer, and I'm telling Postgres this column employee ID is a foreign key that's going to reference on my employee table this ID column. The other way to write this is I have two lines where first I make the column. And let me scroll up a bit here so we can. Yeah, yeah, they do it a little differently here because this one's constructed a little differently because employee ID is also being used as a primary key here, which I'm not doing for better or for worse. So let me I'll code this out and then I'll shift away from this so we don't get too lost in the sauce. So the other way to do this is first I make the column and then I add the foreign key constraint to it. And there are some minor differences in how I'm naming things. So both of these do the same thing. And this is actually a really good thing to touch on. And this is true for any constraint. Like, you can add constraints after creating like a column field. Like if I wanted to do unique insurance ID, I could add it this way. Sometimes you need to, most of the time it's easier, to just do it all on one line. And so that's actually what's going on here is in example number 2, I'm creating this column and then I'm adding a foreign key constraint to that column. And we can see that this bit right here is the same for both of these, where this references keyword says, hey, when I make this foreign key, here's the other table I'm pointing to, and here's the column that we should use to point to on the other table. Because if I really wanted to, I could have this point to some other employee column. But most of the time, we just have it point to the primary key on another table. So these are two ways of doing the same thing. I would recommend doing it this way because it's shorter and simpler, and I think it will be easier to get used to. And this just adds a little bit of extra work that we don't need right now. But they both do exactly the same thing. Does that help break it down a bit?
Yes, I can actually see it. Thank you.
Yeah, absolutely. And thank you for touching on that because there were like a number of small differences in how I wrote the code versus the curriculum. And especially with SQL, the syntax is a little persnickety. So I think this is good to go over. I think the most important thing that I would recommend for you guys is, as you can see, like, everyone has, I think, minor differences in code style. Right now, I think the important thing is to just try and make sure that when you're writing SQL, you're kind of doing it the same way every time. And later on, if you decide you want to switch up your style, or if you get some feedback that actually this way is a bit more best practice, you can. But the way to avoid like bugs is just to kind of be consistent, and then you can always kind of change the approach later. And I also do recommend, this is why I think like making diagrams or even just some notes before writing the SQL helps, because that way if I get a little lost in the sauce on my syntax, I still have a good idea of big picture what I'm trying to accomplish with my SQL code. Yeah, great question. What other questions do folks have, or what else is on people's minds before we take a break? Okay, let's go ahead. Let's take 5. And when we come back, we'll dive more into relationships, right? Because we've been spending a lot of time with the foreign key. Let's see how I can set up a one-to-one relationship, which is sort of our next step here, so that an employee will always have exactly one private data row. A one-to-many relationship that we'll build for a different scenario, and then a many-to-many relationship. So thank you guys, and let's return in 5 minutes. All right. So I've copied over this code that we were looking at into another file, because now that we've dug into how we use the foreign key and some of what it's doing, let's talk about different kinds of relationships. Because what I want to have happen is that for each employee, there's one and only one private data row. So right now, if I go ahead and I copy this, and let's comment out this one that we know is going to throw an error. So right now for employee with ID number 3, which is Carol, somehow our program has made a mistake. And we are about to give her 2 rows of private data. And let's watch this in action. And let's see, error relation private data does not exist. And I think I introduced I don't think that would have introduced an error. I was commenting and uncommenting things. I have a trailing comma. So this is always the challenge with SQL. It is just more persnickety. So let's try this again. And now we see our insertion statements. And so now if I look at my employees, and let's do select star from employee. I've got Alice, Bob, and Carol. And if I look at private data, I see that Carol has 2 rows here, right? And this is not what we want. This is not good data integrity. This is a one-to-many relationship, right? If I had an author who was publishing multiple books, this is what we would want, but not in this case. And the good news here is that we can solve this really easily by adding a unique constraint. And I'll leave that there for the moment. And simply by saying unique, and we'll add not null for good measure, this will solve that problem. Because now, if I have 2 rows with employee ID 3, that's violating my unique constraint. So my foreign key now has to be unique. And now if I run this code, we see this error. Duplicate key value violates unique constraint. Key employee ID 3 already exists. If I look at my private data, and I had something pop up on a different screen, we see that duplicate employee ID that violates the unique constraint is rejected. Right? And this is how I can construct a one-to-one relationship. So to create a one-to-one relationship, add a unique constraint on my foreign key. And you could do it here on the other example as well. And you can see I've kind of coded this up. But I think for sort of simplicity, I'll just leave the one right here. So I just want to pause and check in and see if folks have questions on what we just did. Cricket, yes, sir.
So you put the unique, that mean, so that unique tracking the whole thing, not only the ID, name and everything. That's why it figured out the last one.
No, it's actually just the ID. It's not worrying about the name or anything else. And the reason it rejected this last one is right here. I have employee ID 3, but then I do employee ID 3 again. If I changed this to, I would need another employee, but if I change that to 4, then it would have worked.
What about you put after 1 and 2, the last line? What's gonna happen?
Which line of code?
The last line, and put in the under 1 and 2.
I'm not sure which line of code to.
Uh, let's say
Here
if
on
you
line,
put
on line
28, 29, after the 32.
Oh, I see. So here I have each of these is a different employee ID, right? Employee ID 1, employee ID 2, and then each of these are these other values for social security number or insurance ID. And these do have to be unique, but those aren't what's causing the issue. So each of these lines is adding a new row of private data, right? If I just have, let's comment out these others for just a moment, and let me go ahead and run this. So now if I look at my private data table, we just have employee ID 1, right, with social security number 123 and insurance ID 234. And that works fine. And because now when I add employee ID 2, these two numbers are different. They don't violate this unique constraint. So this operation will work as well. Right, and we have employee ID 2. But if I was to do this again, and there's other unique constraints on other tables or other columns, right? I added a rule here for social security number and a rule here for insurance ID. And just to make sure I don't run into those rules, I just want to like make up some numbers here. But now, because I'm going to try to insert another row of data that's going to have a duplicate employee ID for number 2, we're going to see our error. And then we see this error, duplicate key violates unique constraint. Key employee ID 2 already exists, and it's this line of code throwing the error because this is a 2. And if we look at the private data table, we see it did not get added. But if I change this to 3, then it will get added just fine. So hopefully that breaks it down a bit. Let's take a look at, I do want to make sure we look at many-to-one relationships so we have enough time to code this out. I do want to point out one thing before we dive into many to one relationships, which is, well, I'll talk about Cascade later. I think we'll stay focused on relationships and we'll come back to cascading later. Let's go ahead and let's build out a many-to-one relationship and see what that looks like. And to do this, we are going to go ahead and we're going to add a departments table to our data model. So I have an employee, I have private data, and now an employee will belong to a department. And let's see if we can't get this draw SQL to refresh itself. It seems to have slowed down a bit. Forgive me, I don't know why, but its zoom seems to be a little finicky. And we'll call this department, and a department will have an ID. It will have a department name, and then that's really it. But an employee will now belong to a department, and we'll call it department ID. And this is going to now be a foreign key that goes to our department. And one department can have many employees, but each employee only belongs to one department. And let's move this over there. So let's go ahead and code this up. And forgive me that draw SQL is for some reason being a little finicky. So I'm going to go ahead and I'm going to create a table named department. And let's go ahead and let's just say drop table if exists department, and let's create a table named department. And it will have an ID. And it will have a name. And the name will be a varchar, and we'll say unique and not null, because every department needs a name, and I can't have 2 departments with the same name. But now we're going to add another foreign key, but this one will be on my employee table. And we'll say department ID references department and then ID. So now an employee can belong to a department. And let me go ahead and just run this SQL to make sure I haven't done anything silly. And we do see a couple errors here, which almost definitely means I have a typo. And I'm seeing I forgot to add a comma here. Again, missing the comma or an extra comma, by far the most common programmer error. And I'm seeing all of these error relations does not exist. And so I wonder, I probably have another typo here, so let's run this again so I can kind of drop table, private data does not exist. That's okay. Create table, error, syntax at or near references. So I did something silly here. And if I'm looking at this, it's easy to forget, but I forgot the column type, right? I have my foreign key constraint, but I forgot to say what type of value is in here. Because foreign key could be a string, it wouldn't be a Boolean, but it doesn't necessarily have to be a number. And now let's try again. And now my code is running. Chris, yes, sir.
No, you're fine. I thought it looked like on line 14 department was misspelled, department ID, but I guess that's still fine too.
What about, that totally is misspelled. That's a good catch, actually. Postgres doesn't care because I can name columns whatever I want. The convention is just when you're creating a foreign key column, give it a name that is the table name underscore and the column. Though you might, basically give it a name that's going to make it easy to understand what it is. So Postgres doesn't actually care about that, but that is indeed a typo that matters for us as programmers. So thank you. And now we see this runs. We see this error cannot drop table department because other objects depend on it. And again, what we're seeing is that once I create these relationships, Postgres knows they exist. And because I have this drop table if exists department here first, Postgres says, hey, if I get rid of all of the data, all of the rows from my department table, what happens to all of these employees that have references to it? So we'll see Cascade in action a bit later, which will say, don't just delete department, but delete everything else that depends on it. But for now, I'm just going to play around with the ordering because it is important to think about ordering. And similarly, and now that I've moved that drop table statement, that error should go away. And we see that running. Similarly, if I had put this create table statement after create table employee, we'll see an error, I think, because I'm trying to create a foreign key reference for a table that does not yet exist. Yep, and we see all these errors, and if we scroll way up, we see error, relation department does not exist, right? And when Postgres is executing our SQL, it's going line by line, top to bottom in order. So I need to create this department table before employee, because otherwise this foreign key is trying to reference something that doesn't exist. So that's a common gotcha as we start to add relationships to our tables. So now we see the notices that we've come to know and love. We see a bunch of inserts. Everything seems to be working fine. If I look at my sort of schema description, we see we have this department table. And if we take a quick look at it, oops, there we go. We see it's pretty straightforward. It's got an ID, it's got a name. Note that Postgres is telling me what other tables reference it. So it is telling me the employee table has a foreign key reference to it. And if I look at my employee table now, I see that we have a new foreign key reference added, right? That our department ID is referencing this department table. Note that my employees don't belong to any department at all. Right? And this is okay because I didn't tell Postgres that this can't be null. Right? So I could have an employee that doesn't belong to a department, that does not belong to a department. If I wanted to make sure that every employee had to belong to a department, I would say int not null. Right? And now I would get all sorts of errors when I run my code. Right? And these errors all say error no value in column department ID violates not null constraint. Now, you know, maybe I want to keep life simple. And in fact, why don't we insert into department name, and let's insert a couple things. Let's have an accounting department. Let's have a marketing department. Let's have an engineering department. And let's just call it like HR. And maybe now I need to kind of know the IDs of these if I wanted to use them for stuff. Like if we wanted to, I could maybe say like default 4 and put everyone in HR by default. But I actually think it makes sense that a new employee shouldn't belong to a department at all. That's okay. And then we can add them later. So I've got departments. I've got data, and I have an extra comma there, and that's what's causing that error. And now if we look at our departments, we see, let's see, syntax error at or near values. Oh, I do need that one there. I wonder what's throwing this error. I don't think it's the commas, or the comments, but just to be safe, let's get rid of our comments. And let's see if we can fix this error real quick. Error, syntax error at or near values, line 3 marketing.
Maybe
So,
take off all the values below accounting.
oh, yep, you're totally right. Thank you. Yep, I'm just so used to doing like single value inserts. Yeah, great call. And now we've got everything inserted. And if I look, I've got my departments. I still haven't added employees anywhere. And so let's go ahead now and let's modify our employee insert statements so that they can belong to some departments. Now, I do need to know my department IDs. Right, let's have Alice be in engineering, which I think is ID 3. Let's have Bob be in engineering, which is also ID 3. And let's have Carol be in accounting, which I think is ID 1. And we see these insert statements succeeded. And if I do select star from employee, I now see that I've got my employees in my different departments. And I just want to pause here and see if folks have any questions. So let's see a couple protections that foreign keys offer, and then we'll look at many-to-many relationships. Let's say I want to find all of my employees that are in the engineering department. We'll talk more about this where clause tomorrow, but when I'm making a select statement, I can say where, and this is like a filter. And now I get the employees that are in the IT department. So if I want to say delete a department, I need to use this where clause. And so let's first test this out. Let's make a query to get the IT department. So I've got in my engineering department, and let's try to delete it. And in fact, we could do where name equals engineering. And when I try to delete this, I get a really interesting error. Update or delete on table violates foreign key constraint, employee department, yada, yada, yada. Key ID 3 is still referenced from table employee. So Postgres knows about these relationships. And if I deleted the engineering department, Alice and Bob would have department IDs that point to something that doesn't exist, right? My data integrity would be broken, and Postgres will not let me do that. So what I could do is let's get rid of Alice and Bob. Delete from employee where name equals Alice. And I, in fact, can't even do that because Alice has a row of private data, right? That references Alice. And this is a bit of a pain. I really would like it so that when I delete an employee, their private data is deleted. And this is where this term cascade comes in. Because I can take care of this, right? Alice has ID 1. If we look at our private data, I see here, here's Alice's private data. So I could do delete from private data where employee ID equals 1, and that will be deleted. And now that's gone. And now I could delete from employee where ID equals 1. And now I've deleted Alice. And if I look here, I see Alice is gone. I would also have to delete Bob, and then I could finally delete the engineering department. However, this is a bit of a pain. And this is where this term cascade comes in. And in fact, let's look this up real quick. So when I make a foreign key, I can decide how deletion is handled with it. I don't know if there's a direct spot in the Postgres docs that describe this well, but they do talk about Cascade a bit. And let's just hop to where they do, and let's take a look at it real quick. So if I add a Cascade, it means that when I delete an employee, its private data will be deleted as well. And let me just go ahead and code this so we can see it in action, because I think that will help, because I'm getting a little lost in the sauce explaining it. And remember, what I want to have happen is when I delete Alice, I want her private data to be deleted as well. So what I'm going to do over here is I'm going to add the onDelete cascade constraint. And I'm actually going to look at this guide code real quick to make sure I get my syntax right on it. And I believe we just add it indeed at the very end. So this line is getting a bit long, right? But we're going to say onDelete cascade. And so onDelete cascade makes it so if I delete employee 1, their private data is also deleted. And let me go ahead and rerun this file. Right, so we now have Alice back in our database. And now let's delete Alice and see what happens. And let me make sure I get my delete syntax right here, because I always get a little lost here. Delete from employee where ID equals 1. And so now Alice is gone. And if I go to the private data table, Alice's private data is also gone. And this is super powerful, right? Because this is what I want. When I delete an employee, I should delete their private data. However, if I delete a department, I probably don't want to delete all of my employees because that could cause a big problem if I make a mistake, right? So using Cascade is very much a design decision. So you have to be really thoughtful about where and when you use Cascade or where you don't use Cascade. So for example, here, we do not use on delete Cascade here because I don't want Postgres to allow someone to delete a department and automatically delete all employees in that department, right? That is a bad design decision. I instead would want to manually get rid of all the employees and then delete the department. However, up here, when I'm using this drop table to, just get rid of stuff for writing code, using Cascade is totally fine. And it does make life easier because I have to worry less about the order of my drop table statements. So now, if I delete private data and private data depends on employee and employee depends on department, this drop will cascade to this, which will cascade to this, and it makes it easier to write and run my SQL. So I just want to pause there and check in and see what questions folks have or what people are curious about, because this idea of how Postgres enforces these rules with foreign keys and ensures data integrity, and then how we can like strategically use Cascade is really important. How are we feeling about what we did here by adding on delete Cascade to our private data foreign key? Cool. All right. Why don't we take 5, and then when we come back, we will talk about many-to-many relationships, which are a little more complex. So I think this is a good time for a break. Just to recap, we covered building a one-to-one relationship between an employee and their private data. And we did this by adding a unique constraint to our foreign key so that in my private data, there can only be one row of private data for each employee. Then we saw how a one-to-many relationship, so that a department can have many different employees, can be really easily accomplished with a foreign key without any modification, just using references. So an employee can now belong to one department, but a department can have many different employees. And then we explored the behavior of Cascade, right? Where we tried some deletions and we saw what the issues that we can run into. And in fact, if we go ahead and let's give an example of deleting Alice, that takes advantage of our on delete Cascade for employee, for private data.employee ID. And we can say delete from employee where ID equals 1. And because private data employee ID has on delete cascade, Postgres will, when we delete Alice, also delete her private data. But I can't delete a whole department. Right? If I tried to do delete from department where ID equals 3, because employees exist in that department and we didn't do on delete cascade for our employee department ID primary key or foreign key. Postgres won't allow the delete. All right, and if I go ahead and run this code, we see everything runs, but then we see this error. Update or delete on table department violates foreign key constraint on table employee because there are still employees in the engineering department. And in fact, let's add a select star from department just to look, right? This way I don't have to keep typing it out. And we indeed see that the engineering department is there despite my attempt to delete it. Tom, yes, sir.
So similar to the delete and cascade, there's also an update one. Is that still pretty useful, or is there a better way of doing that nowadays?
I would have to look at it.
Okay.
Yeah, let's take 5 and actually let's take a look during the break. All right, guys, let me pause our recording. All right, so we've covered a lot of ground. We've seen one-to-one relationships, one-to-many relationships. We dove pretty deep into the behavior of cascade, right? Where we can see how not only can I create a foreign key, but Postgres will protect that foreign key. I cannot delete an employee if they have private data, unless I tell Postgres that that's okay. That when I delete an employee, that should cascade onto this foreign key reference, and it's okay to delete their private data. But on the other hand, if I have a department and employees in that department, and I try to delete the engineering department, but it has a bunch of employees, I do not want to allow that. And so because of this foreign key relationship between an employee and their department ID with the department table, Postgres will not let me delete a department that has employees in it, which is great, right? And now our database can really be giving us data integrity. So the last relationship we're going to look at is the most complex, and it is a many-to-many relationship. And I've gone ahead and I've done a little bit of prep work here, and we are going to be building a data model of students enrolling in different courses. And our data is really simple here. Courses have names and student have names. And our student table is very simple, and our course table is very simple. And I've got students Alice, Bob, and Carol, and courses history, math, and computer science. And so if I run this SQL, we see those tables are created and those students are put in those tables. And so far, we don't have any sort of relationships happening. Now, many to many is actually a bit tricky. And we actually saw this the other day. And let me rename these so they look like what we're expecting. So we have student and course. And I believe I added David as well. And we'll add another row here and we'll talk about the challenge. And let's call this, instead of grade, let's call this student course. And this is an example of what we call a join table. And this is a special sort of table. And we're not going to worry about grades right now. Because my challenge is with the normal foreign key, how do I get Alice enrolled in 2 different classes? Right? I want Alice to be enrolled in math and history. And how do I make it so that I can have in my math class, I can have many different students, and let's enroll Carol and David. Let's enroll Carol and David in there as well. And we might as well enroll Bob in history, right? So I have 2 people in history and the math class, no one's in computer science, I guess. The math class has 3 people in it, but most critically, Alice is in 2 classes at the same time, right? And this is tricky. How do I accomplish this with the normal foreign key? And the answer is I can't. You know, if I had course ID here, like the foreign keys that we've come to know and love, well, I could enroll Alice in history, and I could enroll Bob in history. I could enroll everyone in history, but they're only enrolled in 1 course at a time. So that is not going to work. Conversely, if I'm looking at the course table and I try to put a foreign key over there, well, I could enroll Alice in every single class, but now my classes can't have more than 1 student. So to solve this problem, I actually need to create another table specifically for this many-to-many relationship. And this is what we call a join table. And this is why the table is named student_course, because we are tracking the joining or the many-to-many relationship between students and courses, 1 student in many courses, and 1 course with many students. So before writing code, I just want to pause and check in and see if folks have questions here, sort of on the conceptual side. Okay, awesome. And this is probably the trickiest bit with relationships in Postgres. So that it's okay if this one takes some time. The good news is that implementing it is actually really straightforward. We'll kind of put this here as a reference. And what I can do now is, let's do drop table if exists, and we'll call it student_course cascade. And let's give ourselves a little room, and we'll say create table student_course. And we will give this an ID because it is always useful to put primary keys on stuff. But now what I really want is I want to have a student ID that references student ID. Right? So this is my foreign, this is for my foreign key to my student. And then I want the foreign key to course students enrolled in. And this is my join table. And I can add things to it. I need to remember to put the column type. I always forget that when I'm writing foreign key references. I think this should be not null because I don't want to, this should represent a student joining a course. But that really should be all I need. So let me go ahead and run this code to make sure I don't have any typos in my SQL, and then we'll see this in action. So SQL runs just fine, which is great. Let's see how to use this. Well, Alice has ID of 1, Bob has ID of 2, Carol is ID 3, and David is ID 4. And over here in this diagram, let's see, it was math, history, computer science. So let me go ahead and first of all, let's get a little more real estate so we can kind of see these things together, or I'll just zoom out a bit over here. And let's just reorder this so these IDs will match. And now let's enroll students in courses. So let's enroll Alice in math. Insert into student course, and we'll do student ID course ID, and we'll say values. And let's do this as one big statement just to make life simple. So we will enroll Alice in math, right? And let's enroll Alice in history. And just for fun, let's enroll Alice in computer science. Why not? And now let's enroll Bob in math. Or I guess it's Carol. Let's enroll Carol in math. Right, so Carol has ID 3, math is ID 1. And let's enroll David in math as well. Now, fingers crossed, I don't have any typos. And let's add a select statement, and let's do select star from student course. Let's go ahead and run this SQL. And not make typos while we type it out. And this ran without error. We didn't run into any typos or common challenges. And if we look at this, we see Alice, Bob, Carol, and David are created. Math, history, and computer science are created. And I now have Alice enrolled in math. I have Alice enrolled in history. I have Alice enrolled in computer science. I have Carol enrolled in math, and I have David enrolled in math. Right? And so each row represents one student enrolling in one course, but it's perfectly fine for me to have one student in multiple courses or one course with multiple students. And so this is how you build a many-to-many relationship. And let me, just because I do love drawing, right? Let's take it home and draw this here. And so we can see Alice is enrolled in math. So let me just pause here and see what questions folks have or what might be good for us to dig into with many-to-many relationships. Alex, yes, sir.
So the primary key for the join table will keep duplicates away from
That's a great
double.
point. The primary key is not really doing anything right now. All this primary key does is help us uniquely identify each row. We don't have anything keeping away duplicates right now, in fact, which is something we can add in just a minute. Because indeed, I could enroll Alice in math twice. Which is not what we want, but it will actually work just fine. And we'll see how to fix that in just a sec. All right, and now Alice is enrolled in math twice. You know, we might want to add a grade. So as this primary key ID might have its use to kind of grab this information more easily, or as we refer to things or connect things, it's just usually a good habit to put a primary key on everything, but it's not really doing much right now. Does that sort of answer your question?
Yes. Thank you.
Yeah, great question. Yeah, and we'll see how to solve this problem of how do I keep Alice from enrolling in math twice in just a second. Tom, yes, sir.
Yeah, mine actually kind of follows to his, and it might be the solution. I'm not sure, but I was just gonna ask. So for a many to many, the only time that I saw that we actually used a unique key was for the one to one. So for many to many, is that something that we should try to avoid? And like I said, unless that might be the solution, is to create that unique combo foreign key that you mentioned earlier.
Yeah, exactly. We can use a unique constraint to keep a student from enrolling in the same course twice. So I can say unique student ID, course ID. And the syntax here may not be correct. So let me run this and we'll see how we do. And if we look at all of our SQL messages, and let me give us a little more real estate here. So we see, excuse me, I had things jump on me there. We see the drop table notice, which is fine, that we're used to seeing. We see create table, that's fine, that we're used to seeing. We see our inserts, and then down here, we see error, duplicate key, violates unique constraint, student course, student ID, yada, yada, yada. And at this point, we might even want to name the constraint. Key student ID course already exists. And what's throwing our error is enrolling at Alice in math twice. And because this is all one insert statement, all of these, right, these are not separate SQL statements. So the whole statement failed, right? Our unique constraint says I have to have a unique combination of student and course. So if we comment that out, now this will work fine. And now we see our students enrolled in our courses. As to your question, sort of about when to use this, it's really a design decision based on what it is that, you know, we're modeling with our data. You know, if it's, I don't know, maybe like points in a game, there might be a situation where duplicates is okay. And I want to like count it or something, to see like how many. But obviously for students in a course, we don't want one student to be able to enroll in the same course like multiple times, because that wouldn't make any sense. Does that help answer your question? Awesome. Yeah. And great point about leading us to how we can use this unique constraint to make sure that a student doesn't enroll in the same course twice. So this was really the last thing that we had to cover for today for relationships. We've now seen a lot of different relationships, right? And to kind of finish out our diagram here, let's in fact add our join table. And our join table has one foreign key that's going to point to the student that's enrolling in a course. And then another foreign key that points to the course the student is enrolling in. And so by doing this, I can establish a many-to-many relationship. So many-to-many relationships are a little special. You need a join table to accomplish them, right? For our other relationships, like one-to-one or one-to-many, I don't need an extra table. I can just use foreign keys on my existing tables and some unique constraints. But for a many-to-many relationship, I actually do need this, what's often called a join table. And that's what we see here. And as always, I really think that using a spreadsheet or even a piece of paper is a really useful design tool as we're digging into these concepts. And again, the code is slightly different, but it illustrates the exact same things here in our written curriculum where we have multiple examples. Because there's a couple examples of one-to-many or many-to-one relationships here. And then for our many-to-many relationships, we have a couple different examples. There's the student and courses one that we went through. And then we also have actors in movies, where again, I can see that I want one actor to be in 4 or 5 different movies. And obviously a movie has dozens of actors. So I need a join table, right? And my actor movies join table. Here, we're just writing the foreign key a little differently, but we see that we've got a foreign key connecting an actor to, through our other foreign key, a movie. And so this way I can have many actors in my movies. We have a similar example here with authors and books. And again, I would encourage you guys to maybe like copy and paste this code and run some of it and create sample data. So I think that's a great way to like play around with this. For example, we could just grab, well, I'm not going to copy and paste the code right now, but I think just putting this into an SQL file and writing some insert statements to create some actors in some movies and add some actors in a movie, and it is a great way to play around with this. So these are really valuable skills and they're critical. Everything that we've covered here today will show up on the SQL assessment. And when we get into Django, although Django will be generating SQL, we'll still need to really understand these relationships, and we'll still, in our Python code, be establishing one-to-one or one-to-many relationships. So these are our key concepts that aren't going anywhere. What questions do folks have before we wrap up? Tom, yes, sir.
Can you scroll down to the movie actor example real quick? For that join table, why do they have actor ID, movie ID, and then the foreign keys? Are they just are those first two like holding each actor in each movie? Like what's
No, there's just 2 different ways to write a foreign key. And remember that a foreign key is still a column in a table. Like if I look over here in my student courses, even though these values in student ID and course ID have special meaning that Postgres is aware of, that it's a foreign key, this is still an integer. in a column. So I still have to create that column and I still have to tell Postgres what data type exists in that column. So there's two ways to add constraints. And there's two ways to write foreign keys, and this is just a different way to do it, but it does the exact same thing of what we did over here. This way it just puts it on one line. And it's really dealer's choice. I don't think one way is better than the other.
Got it. So those first two are just establishing that that's part of the foreign key.
Yeah, the way to think about it is this creates a column, and then this adds a constraint. And that constraint happens to be a foreign key in this case.
Got it. Okay. I was just confused because it came before the primary key, so I was very I was just
Oh.
getting confused as to like why
Right.
it was there and then the primary key and then the foreign key. I was like,
I see.
Yeah.
I see. Yeah, in this example, we did put the primary key here. The order that you define the columns in doesn't really matter.
Mm.
I tend to always put primary keys first. I'm pretty sure the intent here was to emphasize that this is a join table by putting those first. Again, I think the main thing is just however you choose to do it, try to just be consistent, because it'll make your life easier. I personally I always put the primary key first, just out of habit. Other people will alphabetize. You'll see all programmers love to argue about the best way to organize things. Good deal. All right, folks. Thank you very much. Hopefully now we're starting to feel like we're really diving into SQL and we can build some relationships and add constraints. And let me go ahead and stop